Hello coders, welcome to my channel. I am Aniket and today we will discuss problem A of Codeforces contest. Let's read the problem. So Papyrus came up with another puzzle for Frisk to solve. Papyrus brought two arrays A and B of length n, allowed the following two operations to be performed. So there are two types of operation. Choose any index I and change it to ai minus 1. So this is first type of operation, and the execution time of such an operation is 1 second only. And the second type of operation is reorder all elements of array A in any way. So the second type of operation is given to you that you can reorder all elements of array in your own way, and the execution time of such an operation is 3 seconds. So you want to convert your array A to array B, and Frisk want to solve the puzzle as soon as possible. So help Frisk determine the minimum time. The objective for this problem is we have to find the minimum time needed to solve the puzzle. What is that puzzle? We want to make our array A equal to array B using these two operations. If there is no solution, simply output minus 1. Minus 1 denote that you can't change this array A into array B. This is the input format where n is denoting the length of the array A and B, and C is denoting the cost of reordering, cost of the second operation. And this are the elements of array A and these are the elements of array B, and we want to convert our array A into array B. Now let's solve the problem. So the first question I want to ask to you is, can you decrease, can you increase the value by any type of operation? Let's say you have array AI, and can you increase it by any type of operation? The answer to this question is no. We are allowed to only decrease. So this will hint us the impossible case, because the first type of operation will do ai to ai minus 1. So you are allowed to only decreasing the value, not increasing that. So now the question arises that how can we determine that our answer is possible. That means we can change array A to array B. That is a possible case. So how can we determine that our answer is possible, so that we can easily change our array A to array B? So what is the answer to this question? So the answer to this question is, we will use the best possible mapping from AI to BI. So what is that best possible mapping? Let's say the array given to you is 2, 4, 5, 3, 6, 8 for array A, and for array B you have BI as 5, 8 and 3 and 1 and 2. So how can you find the best possible mapping from AI to BI, AI to BI, AI to BI? So how can we find the best possible pairing? So for finding the best possible pairing, we sort both array and compare AI to BI. And if in that case, if any case we find that AI is lesser than BI, so we can't change this AI to BI, because we are only allowed to decrease the value. But here in this case AI is lesser than BI, so we can't find any type of operation so that our this AI will be equal to this bi. So this will hint us for impossible case. So what is the array when you sort it? So 2, 3, 4, 5, 6, 8 for A, and B is 1, 2, 3, 5, 5 and 8. If you carefully see in both of this AI and BI, AI is always greater than equal to AI is always greater than equal to BI. So in this case, we can change array A to array B in which number of seconds? So the number of seconds is simply 2 minus 1 plus 3 minus 2 plus 4 minus 3 plus 5 minus 5 plus 6 minus 5 plus 8 minus 8 seconds. This is the AI, and this is the bi, and since ai is greater than equal to bi, so it will give you a non-negative integer. Now let's discuss the impossible case also. So let's say your array is given to you is 1 2 3, and the array b is given to you is 4 5 6. So if you check array of 1, a of 1 is lesser than b of 1. If you find any index where ai is less than bi, so you can't change this array a to array b. So that's why this is impossible to convert. I hope you got this. Now the next question arises that is it always optimal to use reordering cost C to sort the array? Let's see this with an example. Let's say you have an array A with 4, 5, 2 and 3, and you have an array B for 3, 5, 1 and 2. So if you check before reordering or you can say before sorting, is there any condition like AI is lesser than BI? So if you carefully see, AI is always greater than equal to BI. 4 is greater than equal to 3. Similarly, 5 is greater than equal to 5. Similarly, 2 comma 1 and similarly 3 comma 2 also. So that's why we can't find this condition for any I. So that's why we don't need any reordering cost. See, we can simply we can simply convert our array A to B. I hope you got this. So what is the observation from this case? So the observation is whenever you find a index AI is lesser than BI, then only do sorting. Otherwise, you can simply print the number of operations. It will give you the minimum operations. It will give us the minimum operations. Now let's jump to the code, but before that please hit the like and subscribe button so that you can't miss any future explanations of the contest. Now let's move to the code. So here is my simple Java code for the given problem. Here the input is n, which is denoting the length of these two arrays, and c is the reordering cost. So initially I will initialize my flag to true, and this flag will denote the whether we can get a possibility for conversion before reordering. So in this case, there is no addition of cost C. So first of all, our operation is initialized to 0, and whenever I found this type of cases for any index, we will change this flag 1 to false. It will signify that there is no possibility for conversion from AI to BI if we don't consider reordering. And in this case, we will break out of this loop. Otherwise, we will increment our operation by AI minus BI. And if we can't find this type of condition like AI is lesser than BI for any index, so we have to print the operation and simply return from our function. This is the case when you don't consider reordering, but otherwise we have to consider we have to consider reordering cost C. So in this case, first of all, operation is initialized to 0 and flag 2 is initialized to true. So what is the meaning of flag 2? Whether there is a possibility of conversion if whether there is a possibility of conversion if we consider reordering cost. I hope you got this. And I will simply do two pointer approach, and whenever I found that AI lesser than this BI, so I will do flag 2 equal to false. This will signifies that we can't do conversion from A to B. So that's why we will break out of the loop, otherwise we will increment our operation to AI minus BI and simply do I plus plus and J plus plus. If our flag 2 is true, is still true, that means we do not encounter this type of condition. So we will simply print operation plus C. C is denoting the reordering cost that we have to add in our operation. So in this case, you have to print operation plus C, and if the flag 2 is false in this case also, so this is the impossible case. So that's why you have to print simply -1. I hope you understand my code and the intuition behind this code. Please hit the like and subscribe button so that it will motivate me to create such kind of intuitive video for you. Thank you for watching my video.